This is the City of Idaho Falls Erosion and Sediment Control Inspector Training class. My name is Angie Gilman, and my company is called Engineering with a Mission. My colleague, Adam Lyman, who works for Simon Company, and I have put this training together for you. Our goals and objectives for this inspector training class are to give you tools to more easily do your job of inspecting erosion and sediment control BMPs on job sites around your city. Our agenda for this class is to briefly cover the history of the EPA Clean Water Act, the City of Idaho Falls responsibility as it pertains to the Clean Water Act. We'll go over the EPA's Construction General Permit, or CGP. We'll talk about erosion control BMPs, sediment control BMPs, other BMPs, final stabilization, and we'll go over an inspection checklist that you can use in the field. So why are you here today? The EPA created the Clean Water Act in part to make sure that our rivers and lakes are fishable and swimmable. Seems like a good idea, doesn't it? The picture on the right is of the Cuyahoga River in Ohio when it caught on fire in 1969. This helped spur action that ultimately led to the passage of the Clean Water Act in 1972. The City of Idaho Falls is required to do their part to minimize polluting of stormwater that discharges to the Snake River. Part of what the EPA requires is that the city have an ordinance that pertains to erosion and sediment control, and to enforce those ordinances by inspection. The city doesn't have an option but to abide by the EPA's conditions as they pertain to construction. Failure to meet these requirements by the city is a violation of federal law. So why is water quality important? When sediment load increases in a river, the water temperature increases. As that water temperature increases, aquatic plants die, aquatic insects decrease, leaving less food for fish. And high temperatures also mean that certain species of fish can no longer thrive or survive. It also makes recreation less enjoyable. So what does this have to do with you? Well, construction is the leading cause of sediment runoff in urban areas. Under the EPA's Clean Water Act is the National Pollution Discharge Elimination System. The NPDES is over stormwater management for 3 different sectors: construction, industrial, and municipal. The Municipal Separate Storm Sewer System is a sector that applies to the City of Idaho Falls because the city discharges stormwater to the Snake River. Your job is to help contractors do their part to comply with the city's erosion control ordinance. The purpose of the City of Idaho Falls erosion control ordinance is to protect stormwater, groundwater, water bodies, water courses, and wetlands from construction activities pursuant to and consistent with the United States Clean Water Act. Their goal is to manage and control the amount of pollutants in stormwater discharges, soil erosion, sediment discharges, mud and dirt deposits on public roads caused by or the result of construction activities. The Idaho Department of Environmental Quality has jurisdiction over air quality for the entire state of Idaho. That includes regulating fugitive dust on construction sites. The Idaho State Rule requires that all reasonable precautions be taken to prevent particulate matter from becoming airborne. That includes dust from job sites. If a contractor is not doing his part to contain dust on his site, the Idaho Department of Environmental Quality should be contacted. There are consequences for noncompliance. Failure to reasonably control fugitive dust can result in enforcement action, including monetary penalties. As we mentioned before, the EPA's Clean Water Act includes coverage over stormwater from construction activities through the Construction General Permit. The EPA's coverage through the Construction General Permit is for any construction project that disturbs more than 1 acre or more. It also applies to smaller projects that are part of a larger common plan of development. An example of a larger common plan of development would be a subdivision. The Construction General Permit is applicable inside as well as outside the city limits. Okay, let's recap. We've talked about the EPA and the Clean Water Act and why we're doing this erosion and sediment control work. We've talked about the City of Idaho Falls and their responsibility to comply with the Clean Water Act. We discussed the Idaho Department of Environmental Quality as they pertain to air quality on construction sites. And we've talked about the EPA's Construction General Permit and when it applies to construction projects. Okay, we've completed talking about the federal, state, and local requirements. Now we're going to go ahead and talk about the best management practices that you're going to need to incorporate on your project. So just what are BMPs, or best management practices? BMPs are the methods, measures, or practices used to prevent or reduce water pollution, including but not limited to structural and non-structural controls, operation and maintenance procedures, other requirements, scheduling, and the distribution of your construction activities. The different classes of BMPs include erosion control, sediment control, run-on and run-off control, housekeeping and materials management, planning and project management, and post-construction BMPs. So before we talk about them, let's talk about why we need BMPs. We need BMPs because of erosion. Erosion is the detachment and movement of soil material by the action of water or wind. Erosion control is our first line of defense. If we can keep soil from moving in the first place, then we don't have to clean it up someplace else. Our goal is to prevent water from running across our exposed slopes and surfaces as much as possible, and to try and keep soil in place. If we don't have erosion, then we don't have to clean up sediment someplace else. This is a case of an ounce of prevention being worth a pound of cure. So what factors influence erosion? Soil erodibility is a huge one. Silts and fine sands are very erodible, and we have a lot of them in Idaho, whereas clays and heavy gravels are not as erodible. Vegetative cover is another big one. Good vegetative cover provides protection from erosion through roots holding the soil in place, as well as the plants themselves protecting the soil from raindrop erosion. Plants also slow down the velocity of water as it flows over the ground. Reducing the velocity limits how much power the water has to pick up soil particles. Topography is an obvious one. The flatter, the shorter the slope is, the less likely it is to see significant erosion, where longer, steeper ones are much more vulnerable. Climate determines how much precipitation a project site will see. Areas with high annual rainfall are much more susceptible to erosion than arid regions. And finally, season. Regardless of where your project is, constructing it during winter months will definitely impact how much erosion you will need to account for during your project. Now we're going to cover the erosion controls that you might use on your project. The first one will be preserving vegetation. We'll go over slope tracking and slope roughening. We'll talk about mats and blankets and mulching. The number one thing a contractor can do to minimize erosion is preserve existing vegetation. Preserving vegetation is a free BMP. It slows down the velocity of the water, the roots help hold the soil in place, and it also reduces raindrop erosion. So encourage your contractors to minimize disturbing existing vegetation. Encourage contractors to provide positive protection for areas they want to keep undisturbed. Use construction fence to keep areas from being tracked over, reducing your sediment runoff from construction activities. Next is slope tracking or soil roughening. The purpose of this is to hold the soil in place by firming it down. It also helps trap the seeds in the little grooves that are created from the tracks. Also, the roughening from the tracks reduces the flow velocity of the water as it runs over it. Some of the maintenance issues to consider are making sure that you do your slope roughening when you know that there isn't rain in the forecast. Additionally, it's really critical that the soil roughening or the tracking be done up and down the slope and not parallel to the slope. Mats and blankets are another erosion control BMP. The purpose of the mats and blankets is to do temporary stabilization of your slopes. They help to establish vegetation by protecting the seeds as they germinate. They also come in a variety of types, thicknesses, and specifications. Some erosion control mats and blankets are meant to last for 12 months, while others are intended to last up to 3 years. So make sure you get the blanket that's appropriate for your intended use. The key to mats and blankets being effective is proper installation. Seed beds need to be prepared prior to the mats being installed. The mats must be installed from the top down the slope. The mats need to be staked in well all along the slope, and the mats need to be overlapped sufficiently so that there aren't gaps between them. And the most critical is that the mats need to have a really, really good contact with the soil. So the slopes need to be graded prior to the mats being placed. If there are holes or large lumps in the slopes, then the mats, wherever those are, is where soil erosion will take place. Mulching is generally effective for slopes that are steeper than 3-to-1. It's really important that you apply the appropriate amount of mulch and tackifier. More mulch might be required on steeper slopes, while flatter slopes may not need as much mulch. That's the end of our erosion control BMPs. Now we're going to move on to sediment control BMPs. But first, the definition of sediment. Sediment is eroded material suspended in wind or water. It's suspended material that is being moved from its original location. Make sure you understand the difference between erosion and sediment, as there will be a test question about this at the end. Sediment control BMPs include stabilizing your construction entrance, fiber rolls and straw wattles, silt fence, check dams, and inlet and outlet protection. Relative to erosion control BMPs, sediment control BMPs are generally about 50% effective. Erosion control BMPs are more likely to be 90% effective. Therefore, erosion control BMPs should be your first line of defense. A stabilized construction entrance is non-negotiable. It must be required. Make sure that the rock is 2 to 4 inch clean, crushed rock. Round river rock is not acceptable. The depth needs to be approximately 6 inches thick. The width needs to be 20 feet and the length 50 feet. And it needs to be replenished if the rock gets filled with mud. As you're doing your inspections, make sure that these dimensions have been met and let the contractor know if the rock gets too dirty and needs to be replenished. According to the EPA's requirements, track out must be swept the same day. So encourage your contractors to minimize track out, and if it does happen, to clean it up the day that it does. Fiber rolls or straw wattles are an extremely versatile tool for sediment control. Their primary function is to slow down water and to trap sediment. They can be used for perimeter control, as shown in this picture. They can also be used along the toe of hillsides, as well as along contours of hillsides. Again, always make sure that you install fiber rolls along the contour. Make sure you overlap them sufficiently at the ends where they meet. Make sure you have very good contact with the soil for the entire length of the roll, and make sure that it's staked down properly, typically every 4 feet. Maintenance issues associated with fiber rolls and straw wattles include the fact that they're not very durable. They will need to be replaced if they get broken. Additionally, you'll need to muck out any sediment buildup on the back side of them if there's a storm event. Straw wattles are fairly fragile, so if they're in a location where they're going to be driven over, you'll probably need to have the contractor replace those more frequently as they will break. Fiber rolls are very useful, but their uses are limited. It's generally not very good to use them as inlet protection because they're light and they can float. They can be used as check dams for limited situations, but because they are fragile, they will deteriorate quickly. When you're doing your inspections, make sure you check all of the straw wattle to see if any of it is broken or damaged and needs to be replaced. Also check for silt buildup behind them after storm events. That material needs to be removed in order for them to function properly. If any holes develop underneath them, they need to be filled or it'll just get worse. Silt fence is probably one of the most common sediment control BMPs used. Silt fence works by ponding water and allowing sediment to settle out. Silt fence is good for use at the bottom of large exposed slopes, as well as as a barrier around the bottom of stockpiles. Silt fence should never be used in high concentrated flows. It is intended to pond water. Silt fence is absolutely useless if it's installed improperly. It must be trenched in as shown in this diagram to the right. The stakes have to be installed on the downhill side. Additionally, it must be maintained. As sediment builds up behind it, it must be cleaned out in order for it to continue to be effective. It's also really important that silt fence be installed at the same elevation or the same contour line. Installing it up and down a hill is absolutely useless. So take a look at the picture here on the right. What's wrong with this picture? If you were the inspector on this site, how would you direct someone to fix it? Well, there's a number of things. First, the silt fence is installed, at least in part, up and down the hill, which is completely useless. Additionally, it's only being installed at the toe of the slope, and there's no other BMPs further up the hill to slow down the velocity of the water or to impede any kind of runoff. On the left, about halfway up the picture, it looks like someone's tried to use the silt fence as a couple of check dams. This is the wrong application for silt fence. Silt fence is not intended to be used in concentrated flows. Check dams are an excellent sediment control BMP to be used in ditches and swales. The primary purpose of check dams is to slow down the velocity of the water while ponding the sediment behind the check dams. Again, proper installation is key for the effectiveness of check dams. The elevation of the toe of the upstream check dams need to match the elevation of the top of the downstream check dam. Also, the center of the check dam needs to be lower than the sides. Otherwise, water will quickly find a path along the sides and erode them. The check dam on the bottom left is working really well, as evident by how much sediment is deposited upstream of the check dam. But it needs to be cleaned out. Like all BMPs, check dams work best when they're maintained properly. The picture on the right shows straw wattle being used as a check dam. Because they're not very tall, they're only going to work in fairly flat conditions. Also, because they aren't very durable, they shouldn't be expected to last for a very long time. Inlet protection devices are the last chance to stop sediment before it goes into the storm drain system and enters the Snake River. Again, the primary purpose of this BMP is to slow down the velocity of the water and settle out sediment. A variety of options are available for inlet protection, including coconut fiber mats, similar to the one shown up in the right-hand corner, rock-filled bags, as shown in the bottom right, and inlet devices, as shown below. Inlet protection devices must be maintained either by cleaning them regularly or replacing them regularly. You'll want to make sure that you always check the inlet protection devices during your inspections to make sure they're being maintained. Inlet and outlet protection is another important sediment control BMP. Again, the primary function, as similar to other BMPs, is to slow down the velocity of the water and to let the sediment settle out. Use clean, angular rock for your riprap. Make sure that it's wide enough to collect all of the sediment that it needs to. The length will depend on the slope and the soil conditions. The last sediment control BMP we're going to cover is run-on and runoff management. When you're going out to the site to do an inspection, look around the property that surrounds the project and see what sort of existing conditions are there. If there's a potential for water to run onto the site and overexposed soils, there should be some sort of berm, straw wattle, or other device to help route that flow around the site. Conversely, on the downhill side or downstream side of the site, see what's below it that could be affected by runoff. If necessary, let the contractor know that they need to put in some sort of containment to try and keep flows, sediment-laden flows, from running off onto someone else's property or into a storm drain. Now we're going to move on to our next class of BMPs, which is housekeeping or materials management. This group includes debris containment, dust management, storage and proper disposal of toxic materials, and stockpile management. Debris management is a big part of keeping a job site clean. Check to see whether or not the site has a debris container. Check to see that the size of that container is adequate for the project. If there's garbage overflowing, let the contractor know that he needs to have it regularly serviced. The new construction general permit states that all debris containers will be covered when not in use. This may not be practical all the time, but the contractor should have a way of covering his debris container if it's needed. Dust management is really critical for our job sites. Why is dust regulated? We have a lot of very fine silt particles in Idaho. Those silt particles are comprised of silica or glass. So the dust in our air is basically fine, tiny, sharp pieces of glass, which is extremely hazardous. As those fine particles are inhaled, they penetrate deep into lungs, causing lung diseases. They can affect people with impaired lungs as well. Not only is it a health risk, but it's also an air quality issue, and it's a nuisance. Dust management BMPs include stabilizing roadways. This is typically done with a water truck. Also, watering other exposed areas. Preserving existing vegetation. Sweeping, especially at the construction entrance. Stabilizing stockpiles. And saw cutting using water and a vacuum. If you see that dust management is not being done, let the contractor know that it is required by state law that dust management be done to the maximum extent possible. Storage and proper disposal of toxic materials is often overlooked on job sites. If you see on a job site that there are toxic materials, let the contractor know that they need to be stored in a leak-proof container. Oil is considered a toxic material and needs to be stored properly. If a vehicle does require maintenance, make sure that the contractor uses drip pans or some sort of pads underneath the equipment while the maintenance is taking place. If there is some sort of a spill on site, direct them to clean it up immediately and dispose of that material properly. Concrete washout is extremely toxic to any kind of aquatic plants or animals. Concrete washout must be stored in a leak-proof container. This can be as simple as digging a pit and lining it with visqueen and surrounding that with bales. When you're doing your inspections, make sure that the concrete washout is lined. It also needs to be signed very clearly so that subcontractors will use it. Washout rules apply not only to concrete, but also stucco, paint, mortar, caulking, and drywall. If you do have some sort of a spill, make sure you pick it up immediately. During your inspections, make sure you check to see that the porta potty is staked down to protect it, and make sure it's not placed anywhere near a curb and gutter or storm drain inlet. Check to make sure that the contractor has a spill kit on site, as that is required by the EPA's construction general permit. Encourage the contractor to avoid fueling and maintaining vehicles on site if at all possible. Also remind them that they need to sweep their construction entrance daily to make sure that track out is not an issue. Let your contractor know that illicit or illegal discharges are a big thing to the Environmental Protection Agency. An illicit discharge is defined as any discharge to the MS4 or storm drain system that is not composed entirely of stormwater, except for those discharges that are allowed under an EPA permit. Allowed discharges are limited to fire hydrant flushing, landscape irrigation, wash water that doesn't contain any kind of soap or solvents or detergents, water used for dust control, and water used for flushing water lines. For the complete list of allowable discharges, see the current construction general permit for our area. Next is stockpile management. If a stockpile is going to be sitting unused for 14 days, it must be stabilized. That can be done through a variety of methods, either covering it with a tarp, mulching it, putting on temporary seating, applying straw and a tackifier. There's a lot of possibilities. But again, the critical thing is that it be stabilized if it's going to sit unused for more than 14 days. For dust control purposes, the top of the stockpiles should be flattened. When construction is getting ready to start on a project, talk with the contractor about how to phase the project to minimize exposed soils. Also, if there's going to be dewatering during the project, make sure that that dewatering plan is included with the erosion and sediment control documents approved by the city. If it was unknown at the time of the start of the project and it suddenly becomes an issue during construction, have the contractor stop and submit a dewatering plan for review and approval before they start work. If the contractor is going to be dewatering into any kind of surface water, such as a Snake River or any other surface water, make sure they understand the requirements of the construction general permit. Turbidity monitoring is required by that construction general permit if dewatering to surface water is going to be done. Okay, so you get the call that a project is complete and they're ready for you to come and do final inspection. One of the most important things to note is that post-construction BMPs include anything that's used to stabilize a site on a permanent basis. This can include anything that covers bare soil, such as asphalt, concrete paving, buildings, landscaping, gravel, etc. Again, there should be no bare soil on the site once construction is complete. Per the construction general permit, the contractor must achieve 70% revegetation for the site to be considered stable. Remind your contractor during the construction project that one of the best BMPs they can use is achieving final stabilization through revegetation. Encourage them to seed or sod any of the areas that have been final graded. Once you get to the end of the project, make sure that they understand that 70% revegetation requirement. The other option is to have them use temporary erosion control measures along with seed to achieve that 70% coverage. Temporary erosion control measures can include straw blankets or mats and wattles, and also placing a tackifier and mulch over that seed. So what's your role as an inspector throughout the life of a project? Well, before a contractor breaks ground, make sure that all the PMPs are installed properly and where they should be. During construction, make sure that all the erosion and sediment control minimum requirements are covered, such as stabilizing the construction entrance, having a waste container, having a concrete washout. Make sure that all the BMPs are maintained throughout the duration of the project. And at the close of construction, check to make sure that all bare ground is stabilized. Make sure that all the temporary BMPs are removed, including the drop inlet protection devices. And make sure that all trash has been picked up around the site. So what should you be looking at when you're doing your inspections? First, check all exposed surfaces. Look for any signs of visible erosion. Let the contractor know where they're at so they can stop those so they won't get any worse. Check the entire perimeter of the site and look for any signs of discharge that's leaving the site. Look at all discharge points, including curb inlets and culverts. Make sure that any unauthorized discharges are not occurring. Check all of the BMPs that were installed. Ensure they're all functioning properly and identify any maintenance issues. If you see maintenance issues, point those out to the contractor. Also, look at all storage areas. Check and make sure there's proper cover and containment of any toxic materials. Look around and see if you can identify any other potential sources of pollution, and let the contractor know what needs to be done about it. During your inspection, if you notice that the contractor is dewatering 2 waters of the U.S. or appears that he has, document it and note whether or not it appears to have met water quality standards. Take pictures and include them with your inspection report. Make sure that your inspection reports are very clear and thorough. Make sure that there's a backup inspector so that if you're not available, someone else will be able to follow up on any outstanding issues. And take photographs and include them in your inspection reports in case you're not around in the future and someone else needs to go out and complete the inspections for that project. When you're doing your inspections, it's a good idea to have a checklist to make sure that you don't miss any of the BMPs. Here's an example of a site preparation inspection checklist. Look through this list as you get to a job site and make sure that all the things that apply have been installed prior to the contractor breaking ground. Here's an example of a final checklist to use at the end of a project. Make sure again that all bare ground is stabilized. Make sure that revegetation has been achieved. Make sure that all those temporary BMPs have been removed, especially those drop inlet bags. Make sure the trash bins have been removed and any litter or debris around the site has been cleaned up. All right, you've made it through this class. Let's just go over what we talked about. We talked a little bit about the history of the EPA and the Clean Water Act and why we're doing erosion and sediment control. We also went over the city of Idaho Falls and their responsibility as it applies to the Clean Water Act. We talked about the EPA's construction general permit. And then we went over all the various BMPs that you might find on a typical job site. And lastly, we went through a couple of example checklists that you could use while you're doing your inspections. I hope that you found this class to be helpful. Best of luck in doing your part to make sure that the City of Idaho Falls complies with the EPA's Clean Water Act requirements.